Earthquakes are a natural phenomenon that occurs when there is a sudden release of energy in the Earth's crust, resulting in the shaking or trembling of the ground. These events are caused by the movement of the Earth's tectonic plates and are a common geological occurrence. Earthquakes and volcanoes are examples of sudden movements which originate from inside the Earth. We have already seen the types of volcanoes. But what is an earthquake? To put it simply, an earthquake is the shaking of the Earth. An earthquake can be defined as a sudden violent shaking of the ground as a result of movements in the Earth's crust or volcanic action. These movements result in the release of energy along a fault and cause the Earth to shake. An earthquake, like a volcano, is a type of endogenic process. Earthquakes. Points you should not miss. The network of seismographic, which is the instrument used to measure earthquakes, stations all over the world record dozens of earthquakes every day. Most of them are not felt by human beings as they are minor quakes only. The occurrence of a severe earthquake is limited to a few regions in the world. The point within the Earth's crust where an earthquake originates is called the focus, hypocenter, or seismic focus. It generally lies within a depth of 6 kilometers in the Earth's crust. The point vertically above the focus on the Earth's surface is called the epicenter. The intensity of the earthquake will be highest in the epicenter and decrease as one moves away. All natural earthquakes take place in the lithosphere, that is, the region that constitutes the Earth's crust and rigid upper part of the mantle. Focus and epicenter of an earthquake. Causes of earthquakes. Earthquakes are primarily caused by the movement of tectonic plates beneath the Earth's surface. These plates are large sections of the Earth's crust that float on the semi-fluid layer of the mantle. There are 3 main types of plate boundaries where earthquakes are common. Divergent boundaries. Plates move away from each other, creating tension and often resulting in earthquakes. Convergent boundaries. Plates move toward each other, leading to compression and causing earthquakes. Transform boundaries. Plates slide past each other horizontally, generating shear stress and causing earthquakes. Earthquake waves or seismic waves. The earthquake which originates in the lithosphere propagates different seismic waves or earthquake waves. Earthquake waves are basically of 2 types: body waves and surface waves. Body waves. They are generated due to the release of energy at the focus and move in all directions traveling through the body of the Earth, hence the name body waves. They travel only through the interior of the Earth. Body waves are faster than surface waves, and hence they are the first to be detected on a seismograph. There are 2 types of body waves: primary waves and secondary waves. Primary waves, also known as P waves, are the fastest body waves, traveling at twice the speed of S waves. They are the first to reach during an earthquake. P waves are similar to sound waves. That is, they are longitudinal waves, where particle movement is in the same direction as wave propagation. These waves can travel through solid, liquid, and gaseous materials. As they move, they create density differences in the Earth's material, leading to stretching and squeezing. Secondary waves, or S waves, arrive at the surface with a bit of a time lag after the primary waves. They are slower than P waves and can pass only through solid materials. This specific property of S waves led seismologists to conclude that the Earth's outer core is in a liquid state. In fact, the entire zone beyond 105 degrees from the epicenter does not receive S waves. S waves are transverse waves, meaning the directions of particle movement and wave propagation are perpendicular to each other. When body waves interact with surface rocks, a new set of waves is generated called surface waves. These waves move along the Earth's surface. Surface waves are also transverse waves, where particle movement is perpendicular to the direction of wave propagation. As a result, they create crests and troughs in the material they pass through. Surface waves are considered to be the most damaging waves. 2 common types of surface waves are love waves and Rayleigh waves. Love waves. This kind of surface wave causes horizontal shifting of the Earth during an earthquake. They are much slower than body waves, but are faster than Rayleigh waves. They exist only in the presence of a semi-infinite medium, overlain by an upper finite thickness. Confined to the surface of the crust, love waves produce entirely horizontal motion. Rayleigh waves. These waves follow an elliptical motion. A Rayleigh wave rolls along the ground just like a wave rolls across a lake or an ocean. Because it rolls, it moves the ground up and down and side to side in the same direction that the wave is moving. Most of the shaking felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves. Shadow regions of waves. We already discussed that P waves pass through all mediums, while S waves pass only through solid mediums. With the help of these properties of primary waves, seismologists have a fair idea about the interior of the Earth. Even though P waves pass through all mediums, they cause reflection when they enter from one medium to another. The variations in the direction of waves are inferred with the help of their record on seismographs. The area where the seismograph records no waves is called the shadow zone of that wave. Accordingly, it is observed that the area beyond 105 degrees does not receive S waves, and the area between 105 degrees to 140 degrees does not receive P waves. Measuring earthquakes. Seismometers are the instruments that are used to measure the motion of the ground, which includes those seismic waves generated by earthquakes, volcanic eruptions, and other seismic sources. A seismograph is also another term used to mean seismometer, though it is more applicable to older instruments. The recorded graphical output from a seismometer or seismograph is called a seismogram. Oh, and a quick note, do not confuse seismograph with seismogram. A seismograph is an instrument, while a seismogram is the recorded output. There are two main scales used in the seismometers, the Mercalli scale and the Richter scale. The Mercalli scale represents the intensity of the earthquake by analyzing the after effects, like how many people felt it, how much destruction occurred, and so on. The range of intensity is from 1 to 12, also read avalanche types, causes, and mitigation. The Richter scale represents the magnitude of the earthquake. The magnitude is expressed in absolute numbers from 1 to 10. Each whole number increase in the Richter scale represents a 10-fold increase in the power of an earthquake. There are two well-defined belts where earthquakes frequently occur, the Circum-Pacific Belt and the Mid-World Mountain Belt. About 68% of earthquakes in the world occur in the Circum-Pacific Belt. The Mid-World Mountain Belt extends from the Alps, with extension into the Mediterranean, the Caucasus, and the Himalayan region, and continues to Indonesia. 21% of earthquakes are occurring in this belt. The remaining 11% occur in other parts of the world. Earthquake zones of India.